How do I make an HTTP request in JavaScript? There are several ways to make an HTTP request in JavaScript, but some of the most commonly used methods include using the XML HTTP request object or the fetch function.to. Use the XML HTTP request object. You would create a new instance of the object, open a connection to the server, and then send the request. Here is an example of a simple GET request. Var xhr equals new XML HTTP request, xhr.open, get, https://example.com, true, xhr.send. To use the fetch function, you would call the function and pass it the URL you want to request. Here is an example of a simple GET request using fetch https://example.com, then, response equals response.text, then, data equals console.log, data.catch, error equals console.log, an error occurred, plus error. Additionally, the fetch function returns a promise, which can be handled using .then and .catch. You can use both of these methods to make POST request and send data with it. What is console.log? Console.log is a method in JavaScript that allows you to output data to the console. The console is a command line interface that is typically used for debugging purposes, and it is usually found in the developer tools of a web browser such as Chrome, Firefox, or Safari. The console.log method takes one or more arguments and outputs them to the console. The output is typically preceded by the string console to indicate that the output is coming from the console. For example, the following code would output the string hello, world, to the console, console.log, hello, world. You can also output variables, objects, arrays, and other complex data types using this method. Let myArray equals a, b, c, console.log, myArray. This will output the array, a, b, c, in the console. You can also use other methods like console.info, console.error, console.warn and console.debug to output different kind of messages to the console. What is the cheapest home internet provider? The cheapest home internet provider will vary depending on your location and the type of service you are looking for. In general, the most affordable options are typically basic internet plans from providers such as AT&T, Xfinity, and Spectrum, which offer download speeds of up to 100 megabits per second for around $40 or $50 per month. Other low-cost options include DSL and satellite internet service, which can be found for around $50 or less per month. However, it's important to keep in mind that the cheapest option may not always be the best option for you. It's also important to consider factors such as the reliability of the service and the quality of customer support when choosing an internet provider. It's also recommended to check if there is any government program in your area that provide internet service at reduced cost. It's a good idea to check with internet service providers in your area to compare prices and plans, and to see if any promotional deals or bundle options are available. How much processing power do you have? I am a language model called ChatGPT, which is based on the GPT-3 architecture. The GPT-3 model used to train me has 175 billion parameters, which means it has a lot of processing power and can understand and generate human-like text. This processing power allows me to understand and generate text in a wide range of styles and on a wide range of topics. However, I am a software model running on computer servers, and the processing power available to me is determined by the hardware that I am running on. What hardware are you running on? I am a software model running on computer servers that are operated by OpenAI. I do not have access to the specific details of the hardware that I am running on, but I can tell you that the servers used to run GPT-3 are high-performance machines that are optimized for deep learning. They likely include a combination of multi-core CPUs, high-performance GPUs, and a large amount of memory. These servers are built to handle the massive computational requirements of training and running large language models like GPT-3. OpenAI team uses a custom-built hardware, specifically designed to support large-scale machine learning workloads with high memory bandwidth and low-latency communication between GPUs. This allows them to train models like GPT-3 on massive amounts of data, which is essential for achieving high performance and accuracy. Rolling motion, gyroscopes, very non-intuitive rolling motion and gyroscopes can be quite complex and non-intuitive to understand, particularly when it comes to the physics behind them. Rolling motion refers to the motion of an object that is rolling along a surface, such as a ball or a wheel. The physics of rolling motion involve concepts such as angular velocity, moment of inertia, and friction. It's important to understand that when an object is rolling, it's both rotating and moving in a straight line. A gyroscope is a device that uses the principles of angular momentum to maintain a stable orientation. Gyroscopes consist of a spinning wheel or rotor that is mounted in such a way that it can rotate about one or more axes. The spinning rotor creates an angular momentum that resists any changes to the orientation of the gyroscope. This makes gyroscopes useful in a wide range of applications, such as navigation, stabilization, and control systems. Both rolling motion and gyroscopes can be very counterintuitive because they rely on angular momentum, which is a property of an object that is difficult to visualize. Many people find it hard to understand why a rolling object would keep moving in a straight line and why a spinning wheel would be able to resist changes in its orientation. Understanding the physics behind these concepts requires a good grasp of mathematical concepts such as vectors and calculus. Mathematical concepts such as vectors are mathematical objects that have both magnitude and direction. They can be used to represent physical quantities such as velocity, acceleration, and force. In physics and engineering, vectors are often used to describe the motion of objects and the forces acting on them. A vector can be represented as an arrow, with the length of the arrow representing the magnitude of the vector and the direction of the arrow representing the direction of the vector. Vectors can be added and subtracted using vector algebra. When two vectors are added together, the result is a new vector that starts at the beginning of the first vector and ends at the end of the second vector. Vector algebra also allows to perform scalar multiplication and dot product. Scalar multiplication is the process of multiplying a vector by a scalar, a number. Dot product is an operation between two vectors that results in a scalar value. Vectors are used in many branches of physics, particularly in mechanics, where they are used to describe motion and forces. They are also used in other fields such as electromagnetism, thermodynamics, and fluid dynamics. Understanding vectors and vector algebra is essential for understanding many physical phenomena, and is an important tool for solving problems in physics and engineering.